At 6:17 in the morning, the egg belts on the first tier of a Acre Farms laying house in Indiana begin their daily collection run. The house holds 1.2 million hens. The belts run the full length of the building, 600 feet, carrying eggs from the cages toward the collection end where the processing equipment waits. A hen that laid her egg 20 minutes ago watches it move away on the rubber belt surface. She will lay again in approximately 25 hours. The belt will collect that egg too. This house is one of dozens that Acre Farms operates across Indiana, Iowa, North Carolina, and additional states. The company manages approximately 18 million laying hens in total. Those hens produce more than 2.5 billion eggs annually, enough to give every person in the United States approximately 8 eggs each from this single company's operations alone. Acre Farms is, by the standard definitions, a family business. Founded by David Rust in 1940 with a small flock in Seymour, Indiana, the company has remained in family ownership through 3 generations and grown into one of the 5 largest egg producers in the country. The family nature of the ownership does not make the operation small. It makes the concentration of decision-making authority in a single family's hands over a multi-state, multi-billion egg production system one of the defining facts about how Acre operates and how it has grown. The processing equipment at the end of that Indiana collection belt can handle 360,000 eggs per hour, not per day, per hour. The speed at which eggs move through Acre's grading and packing systems is the rate that a production scale of 18 million hens requires. The laying hen that produces Acre's 2.5 billion eggs annually is a commercial white leghorn, a breed developed over the 20th century specifically for the single purpose of converting feed into unfertilized eggs at the maximum biological rate the hen's physiology allows. The wild ancestor of the domestic chicken produces eggs seasonally, driven by day length and the reproductive logic of raising a clutch of chicks to independence. The commercial leghorn has been selected across hundreds of generations to suppress those seasonal instincts entirely and produce eggs continuously at a rate that approaches the biological maximum, approximately 300 to 320 eggs per year per hen, compared to the 40 to 60 that a wild bird might produce. This performance comes from 2 primary genetic advances. First, the hen's egg cycle was compressed from the naturally longer interval to approximately 25 hours, the shortest biological interval that the egg formation physiology allows. An egg requires roughly 20 hours to form in the shell gland before it moves down the reproductive tract. The remaining 5 hours represent the transition between the passage of one egg and the beginning of the next. Second, the hen's sensitivity to seasonal day-length signals was reduced, allowing artificial lighting programs in the laying house to substitute for natural day length and maintain the production-promoting photo period year-round. The specific genetic lines that Acre uses, primarily highline or Lohman white strains, produce pullets, the young hens before they begin laying, that grow to laying readiness by 17 to 18 weeks of age. From that point through approximately 72 to 76 weeks of total age, they produce at the rates these genetics have been selected to deliver. Acre's pullet-raising facilities are the company-owned operations where the replacement flocks that sustain 18 million hens in continuous production are raised from day-old chick to laying-ready pullet. The pullet operation is not glamorous. It is essential. Without a continuous supply of 17-week-old pullets to replace hens at the end of their laying cycle, the 18 million hen inventory would decline over time and production would fall. At 18 million hens, the annual replacement requirement is substantial. If the average hen stays in production for 60 to 70 weeks before the flock is replaced, Rose Acre must introduce approximately 14 to 18 million replacement pullets per year across its facilities. That replacement flow requires the pullet operation to function as a pipeline. Continuous inputs of day-old chicks converting to a continuous output of laying-ready pullets on a schedule precisely matched to the turnover of each laying house. Rose Acre operates multiple housing systems across its facilities: conventional battery cage, cage-free, and free-range, because the retail and food service market increasingly demands differentiation that a single housing system cannot provide. The conventional battery cage system that represents the company's historical production base houses hens in wire cages arranged in tiers, with automated feeders, nipple drinkers, and the collection belts that carry eggs from each cage row to the processing end. Each hen in a conventional cage has approximately 67 square inches of floor space, a footprint slightly smaller than a standard sheet of paper. This density is the economic logic of conventional cage production. The space efficiency allows more hens per square foot of building footprint, reducing the per-egg fixed cost of housing. California's Proposition 12 and similar legislation in other states has imposed minimum space requirements. Initially, 1 square foot per hen for cage-free systems, and further requirements for free-range systems, that conventional cage housing does not meet. Rose Acre's conventional cage inventory cannot legally supply California's egg market or satisfy the retail purchase commitments that major grocery chains have made to source only cage-free eggs by specific dates. The company has invested in cage-free housing in response, building new cage-free facilities and converting some existing buildings. A cage-free house managing the same hen population as a conventional house requires significantly more floor space. Cage-free hens live on litter-covered floors with perches, nest boxes for laying, and sufficient horizontal space to move, flap wings, and engage in the behavioral repertoire that cage-free certification requires. The same 1.2 million hens that fit in a conventional cage house at 67 square inches each cannot physically fit in a cage-free house of the same footprint. The cage-free facility covering the equivalent hen inventory requires multiple times the building footprint. This square footage math explains the capital intensity of the cage-free transition that Rose Acre and every other major egg producer is navigating. Converting existing conventional inventory to cage-free production doesn't involve simply removing cages from existing buildings. It involves building new, larger facilities while retiring or converting existing ones. A capital expenditure program that runs into hundreds of millions of dollars for a company managing 18 million hens. Free-range production adds the outdoor access requirement that cage-free does not mandate, requiring that hens have access to the outdoors for at least part of each day. managing outdoor access for hundreds of thousands of hens at a single facility, providing outdoor space, managing the biosecurity risks that outdoor access introduces, protecting against predators, adds operational complexity and cost that free-range pricing must compensate. The processing line that runs at 360,000 eggs per hour is where the biological production of 18 million hens converts into a retail commodity. Eggs arrive at the processing end of the laying house on the collection belts, transferred to a conveyor system that moves them into the grading and packing equipment. The first stage, washing, runs eggs through a warm water wash at approximately 20 degrees above egg temperature, which standards required to prevent bacteria from being drawn through the shell pores by a thermal gradient that would occur if cold water hit a warm egg. Automated candling follows. In traditional egg processing, candling involved holding each egg over a light source and visually inspecting for cracks, blood spots, or other defects visible through the shell. Modern high-speed grading lines replace the human candle and inspect step with cameras and sensors that image each egg at multiple wavelengths, detecting surface cracks, internal defects, and blood spots at throughput speeds that no human inspector could match. An egg, moving at the processing line speed, passes through the inspection system in fractions of a second. The grading that follows sorting separates eggs by weight into the USDA weight classes that retail packaging specifies: jumbo at 30 ounces per dozen, extra large at 27 ounces, large at 24 ounces, medium at 21 ounces, small at 18 ounces, and peewee at less than 15 ounces. The automated weight grader routes each egg to the packaging station for its weight class as it passes over the scale. At 360,000 eggs per hour, the weight grading system makes and executes these routing decisions 6,000 times per minute. The packaging machinery loads sorted eggs into cartons. The standard 12-egg carton for retail, the 18-egg carton for certain formats, the 30-egg flat for food service, at speeds calibrated to the grading line's output. A carton loading machine that can't keep pace with the grading line creates a backup that eventually stops the entire line. The integration between grading speed and packaging speed is engineered to match. The feed mills that Rose Acre owns and operates supply the rations that keep 18 million hens producing at commercial rates. A laying hen's feed requirement is approximately 0.25 pounds per day, modest by livestock standards. At 18 million hens, the daily feed demand across the entire Rose Acre system runs to 4.5 million pounds, 2,250 tons per day. That volume requires dedicated milling capacity positioned close enough to the laying facilities to make feed delivery economical. Layer rations carry specific nutritional requirements driven by the biology of egg production. Calcium is the most demanding. Each eggshell requires approximately 2 grams of calcium to form, and a hen producing 300-plus eggs per year deposits 600-plus grams of calcium in shells annually, while also maintaining her own skeletal calcium stores. The ration supplies this demand through limestone and oyster shell additions that bring dietary calcium to 3.5 to 4% of total diet, far above what any cereal grain-based diet provides naturally. Vitamin D3 is required for calcium absorption. Without adequate vitamin D3, the hen cannot utilize dietary calcium efficiently, and shell quality suffers, producing thin-shelled or soft-shelled eggs that break on collection belts or in grading equipment. Vitamin D3 deficiency at scale translates directly into downgraded product and lost revenue. The protein and amino acid profile of the layer ration affects both egg production rate and egg size. Higher dietary protein, specifically the amino acid methionine, supports larger eggs. When Rose Acres' marketing team identifies that its retail customers are short on large-grade eggs and long on medium, the nutritional team can adjust ration amino acid levels to shift the flock's egg size distribution toward the large grade over several weeks. Feed formulation is a production management lever, not only a cost input. The avian influenza risk that Rose Acre manages across 18 million hens spread across multiple states is the most severe biological threat the operation faces, and the most uncontrollable. Highly pathogenic avian influenza, HPAI, kills infected flocks with near 100% mortality within 24 to 48 hours of the first bird showing clinical signs. The 2022 to 2023 HPAI outbreak in the United States killed approximately 58 million birds, the largest HPAI outbreak in American history, and drove retail egg prices to historic highs as supply contracted suddenly. A large Rose Acre facility housing 1.2 million hens represents a single site where a confirmed HPAI detection triggers mandatory depopulation of the entire flock under USDA protocols. The financial consequence of losing a 1.2 million hen flock, the birds, the egg inventory in the facility, the weeks of lost production during cleanout and repopulation, is measured in millions of dollars per site. The biosecurity protocols that Rose Acres facilities operate under attempt to prevent that introduction. Vehicle sanitation stations at facility perimeters, shower-in/shower-out requirements for personnel entering production areas, bird exclusion netting, or screened ventilation that prevents wild bird entry into laying houses, visitor restrictions, and sentinel bird monitoring that detects unusual mortality before it reaches a reportable level. All of these measures address the HPAI introduction pathways that epidemiological evidence has identified. The wild bird reservoir for HPAI, waterfowl and shorebirds that carry the virus without clinical illness and shed it in feces, migrates across North America on pathways that cross the agricultural regions where commercial laying operations concentrate. The fall and spring migrations represent peak risk periods when wild bird density in agricultural areas increases and the probability of wild-to-domestic transmission rises. Rose Acres' multi-state geographic footprint creates both risk and resilience. A single HPAI outbreak at one facility affects that facility. It does not directly affect facilities in states not currently experiencing HPAI activity, which means the company's total production capacity absorbs the loss from one site while the other sites continue operating. The concentration of 1.2 million hens at a single site creates the catastrophic loss potential from any individual outbreak. But the distribution across multiple states limits the probability that a single outbreak event reaches all sites simultaneously. 2.5 billion eggs per year. Distributed across Rose Acres Regional Distribution Center network, that production reaches retail shelves across the Midwest, Southeast, and mid-Atlantic regions through a cold chain that maintains eggs at 45 degrees Fahrenheit or below, from the packing line through the retail display case. The distribution logistics that move 2.5 billion eggs annually, roughly 6.8 million eggs per day, from production facilities in Indiana, Iowa, and North Carolina to retail distribution centers across multiple states require a transportation infrastructure calibrated to the fragility of the product. Eggs break. They also absorb odors, chill unevenly, and age at rates that depend on temperature consistency throughout the cold chain. Rose Acre's distribution centers serve as the intermediate nodes in the supply chain between production facilities and retail customers. Rather than shipping directly from each production facility to each retail customer, a logistics configuration that would require hundreds of individual shipping lanes, the distribution centers aggregate product from multiple production sites and route consolidated loads to retail customer distribution points. All the consolidation reduces transportation cost and allows Rose Acre to supply retail customers with a consistent product mix regardless of which specific production facility generated the eggs in a given week's order. The family that founded Rose Acre in 1940 with a modest Indiana flock could not have anticipated 18 million hens, 360,000 eggs per hour, and a distribution network serving retail customers across a dozen states. What they built was a pattern of decisions, vertical integration of the feed and pullet operations, geographic expansion driven by production efficiency rather than market proximity, continued reinvestment in processing technology that compounded over 8 decades into the operation that runs today. The belt in that Indiana house keeps moving. 6,000 decisions per minute at the grading line, 2.5 billion per year at the dock. If this look at the vertical integration and industrial scale behind one of America's largest family-owned egg operations gave you a clearer picture of where eggs actually come from, hit the like button and help more viewers find this kind of detailed content. Subscribe for more deep dives into the production systems that run behind everyday food. Drop a comment and tell us where you're watching from. The geography of this audience continues to expand, and hearing where matters to us.